Download this code from codegive.com, link in the description below. Logging exceptions with tracebacks in Python, a comprehensive guide. Logging exceptions with their tracebacks is crucial for debugging and understanding issues in your Python code. It allows you to capture the context of an error, pinpoint the exact location in your code where it occurred, and analyze the sequence of calls that led to the problem. This makes troubleshooting much easier and faster than relying solely on error messages. This tutorial will explore how to effectively log exceptions, including tracebacks, using Python's built-in logging module, along with best practices and considerations for different scenarios, inspired by common questions and solutions found on Stack Overflow. Why log exceptions with tracebacks? Consider the following scenario. If some complex function raises a zero division error, the traceback will tell you 1. The type of error *0 division error. 2. The specific line where the error occurred *return data/len, data, within some complex function. 3. The call stack leading to the error *some complex function was called by transform_data, which was called by process_data. Without the traceback, you only know that some error occurred somewhere in the process, making it difficult to identify the root cause. Using the logging module. Python's logging module provides a flexible and powerful way to record events that occur during the execution of your program. It allows you to *specify logging levels *debug, info, warning, error, critical. *configure log handlers *to output logs to the console, files, network sockets, etc. Customize log message formatting *include timestamps, log levels, module names, etc. Basic setup. First, import the logging module and configure it. A simple configuration that logs to a file and the console might look like this. Logging exceptions with tracebacks. The most common and recommended way to log exceptions with tracebacks is using the logging.exception method. This method automatically logs the exception message along with the traceback information. It's equivalent to calling logging.error, but it automatically includes exception information. In this example, if data is 0, a zero division error will be caught. Logger.exception will log the error message you provide and the full traceback information to your configured logging destination, example my_application.log. Examining the log output. The resulting log entry, in my_application.log or the console, depending on your configuration, might look something like this. This output clearly shows * the timestamp of the event, * the name of the logger, __main__ in this case, which usually is the file name, * the log level, error, * the error message you provided, * the traceback, detailing the sequence of calls and the exact line where the error occurred. Alternative methods, and when to use them. While logging.exception is the preferred method, here are a few alternatives and scenarios where they might be useful. 1. Logging.error, exc_info equals true, * the exc_info parameter can be set to true in any logging call, example logging.error, logging.warning. This explicitly tells the logger to include exception information if one is available. This is useful when you want to log a custom message before the traceback. 2. Traceback.format_exc, * the traceback module provides functions for formatting tracebacks into strings. You can capture the traceback as a string and then log it using any logging method. This gives you more control over how the traceback is formatted and integrated into your log message. However, it's generally less convenient than logging.exception, or exc_info equals true. You're responsible for manually formatting the string. 3. Custom exception handling *. You might have custom exception handling logic where you want to enrich the log message with additional information specific to your application. Best practices and considerations. * Choose the right logging level. * Use error for errors that indicate a serious problem that the application cannot recover from. Use warning for issues that are potentially problematic but don't necessarily halt execution. Use debug or info for less critical events that are helpful for debugging. * Provide meaningful messages. * Don't just log the exception type. Include a concise and informative message that explains the context of the error. Explain why the error happened, if you can. * Handle exceptions gracefully. * Catch exceptions at an appropriate level in your code. Avoid catching exceptions too broadly, example accept exception, without a good reason. If you catch an exception, make sure to either handle it properly, example retry the operation, provide a default value, or re-raise it. * Use contextual information. * Include relevant contextual information in your log messages, such as user IDs, input data, timestamps, and any other data that can help you diagnose the issue. Use f-strings or the dot format method to create dynamic log messages. * Configure logging properly. * Adjust the logging level and handlers based on your environment, development, testing, production. In production, you might want to log to a file and set the logging level to warning or error. In development, you might want to log to the console and set the logging level to debug. * Avoid logging sensitive information. * Be careful not to log sensitive information such as passwords, API keys, or personal data. Consider masking or redacting sensitive data before logging it. * Use structured logging, optional for complex applications. Consider using structured logging formats like JSON to make it easier to analyze log data programmatically. Libraries like struct-log can help with this. * Log at the right place. * The location where you log an exception can be crucial. Generally, log exceptions at the point where you handle them or where you can provide the most context. Code example, putting it all together. This comprehensive example demonstrates * logging at different levels, debug, info, error, critical. * Using logging.exception, and exc_info equals true. * Providing meaningful error messages with contextual information. * Handling exceptions gracefully and logging relevant details. By following these guidelines and best practices, you can effectively log exceptions with tracebacks in your Python applications, making debugging and troubleshooting much easier and more efficient. This significantly improves the maintainability and stability of your code. Remember to adapt the configuration and specific logging statements to the unique requirements of your project.